All right, so today in this video, we're going to turn our attention to word problems. And we're still going to use the quadratic formula, but we're going to be using it to solve word problems. So one thing that all of our word problems are going to have in common is they're going to continually ask for the same information. You just have to know which things they're asking for. So these are some little cheats that I like to use. If they are asking how long something's in the air, or when it hits the ground, when will it land, something along those lines, you want to set the problem equal to 0. So that's a big indicator right there. If the problem asks for max, if you just see the word max at all, that means it's either H or K. If it's a what question, they want K. If you see the word max and it's a when question, or they're like how long until, that means when, that means H. So if they're looking for a time that the max occurs, that's H. If they want to know what the max height is, that's K. If the question asks for the starting height, the beginning height, how high it was before it launched, or something like that, they are asking for the y-intercept, which is C. So most of the problems that we do are going to be asking for that information. So it's just a matter of kind of decoding the problem and figuring out, okay, what the heck do they want? So it might be a good idea just if we go over how to get these things again. So to get H, that's actually part of the quadratic formula. That's actually in it. So it's negative B all over 2A. It's the first and the last part of the song. It's just without the discriminant part. K is when you plug in H for X. So in order to get K, you would need to get H. And then there's 2 ways that we can get C. So most of your problems are in standard form already. You have A, B, C in that order already. So it's actually just going to be the last number. Your other option is just to plug 0 in for X and then simplify. So you can always do that as well. So there's 2 ways that you can get C. And I always put this little hint in for my students, just a friendly reminder, time is always X. So if they're asking you to find the height at 10 seconds, that means plug 10 in for time, plug 10 in for X. All right, so scenario 1, we have a boat that's in distress, so it fires off a flare. The height of the flare is called H, and that height is in terms of meters. That height is dependent on how many seconds go by, and we're going to use T for seconds. So that function can be modeled as such. Now, what all that wordage means is here's the formula that tells you the height based on the number of seconds. So T stands for time, H stands for height. That's why most of these formulas will use H and T. We used to use f of x. That's what we're used to seeing. But word problems like these like to use H and T for height and time. So it doesn't change what we're going to do. It's just a formality thing. All right. Right here's your formula. It's in standard form, A, B, C. So it's not going to change the math we do. All right, question A, it says how many seconds, so how long, until we reach max height. So right there, that word max means it's either H or K. And because they're asking when does it happen, how long until it happens, that means H. Letter B says max again, but it says what is the max height, meaning how high does it go, that's K. So K is a height and H is a when does the height occur. Letter C, it says how high was it before launching. So the beginning height, the starting height, right? That would be before launch. That would be the starting height. That means y-intercept. And then letter D, it says how long would the flare be in the air. That's the same thing as saying when will it land, because once it lands, it's no longer in the air, so time would end. So the word land means equals 0. So you have to realize, you have to read between the lines. Being in the air is the same as being on the land. right, so that's the one we want to make equal to 0. So now that we've identified what the heck each question is asking for, we're just going to go get them. All right, so I'm going to set up my H formula, negative b over 2a. Simplify a little bit, and I'm going to get 3 seconds. Then to get my k, I'm going to take that 3. I'm going to plug it in for x, or in this case, t. Just like that. And that's where I would just pick up the calculator and I would type that whole thing in, just one smooth entry. And it's going to be about 47.1. All right, now letter C is asking for C, and it's right here. This is your A, this is your B, this is your C. So the answer is going to be 3. But if you plug 0 in for X, you can see that, oh yeah, you are going to get that 3. So either way you get it is fine. So C is 3. Now it is just coincidental that you got 3 for both of these. There's absolutely no relation between those two questions at all. It's just purely coincidence. All right, now letter D says we have to set the problem equal to 0, and we have to solve it, which means we're going to need to use the quadratic formula. And because it already equals 0, we can plug them right in as is. So negative b plus or minus the square root of b squared minus 4ac all over 2a. So we're going to set up our quadratic formula. Then we're going to type in the discriminant into our calculator, and we're going to write that number right here. Okay, so don't hold the square root button in yet, okay? Just do the discriminant part like we've been doing. Because oftentimes if you make an error, it's because of the discriminant, so that allows me to track an error a lot quicker. All right. Then you are going to square root this. So when we have word problems, we are going to estimate them because these numbers are nasty decimals, so you're not going to want to work with those. And in real life, we don't talk like, we don't say, I'll be home, or I'll be there in root 20 minutes. We don't talk like that. We just say in about 5.5 minutes or something like that. So we are going to round these off. So the square root of 923 is about 30.4, give or take. And because these are like terms, I can actually put them together. So I'm going to break this into case 1 and case 2. Case 1, I'm going to use the plus sign, and case 2, I'm going to use the minus sign. Now I'm going to caution you, when you type this in a calculator, you need to make sure that you put the tops in parentheses. If you don't, it's going to divide these two numbers and then add. We don't want it to do that. We want to make sure we're adding and then dividing. So if you're going to type it all in one shot, you got to make sure you use parentheses. All right, so for the first one, we're going to get negative 0.1, and then for the second one, we're going to get 6.1. Now, the question was, how long would it be in the air? You can't be in the air for negative 0.1 seconds. That doesn't make sense. So what we do when this happens is we reject any answers that aren't logically, physically possible. Those don't make logical sense. And we just circle the ones that do make logical sense. So that flare would be in the air for about 6.1 seconds. So that's about how our word problems are going to roll. So the more of these that you do, the more you're going to recognize the pattern that these share. And you're going to feel comfortable with your answers because you're going to be used to getting the answers like that. Our other types of word problems are dropped object and launch object problems. And those are more like physics kind of problems. All right. Now I want to make sure we understand the difference. Dropped object would be like if I just stood out here and I was holding an object and I just let it go. Right? I didn't throw it, I didn't put any force behind it, I just stood out here and I just let it go. All right, it's going to fall down because gravity is pulling it towards the earth, right? Launched object is if I take something and I throw it. I can either throw it downwards at the ground or I can throw it upwards in the air, okay? So that's why, like for this, we have a plus or a minus symbol. It depends. Do you throw it down or are you throwing it up? So that's the difference between the formulas, all right? Oops. All right, This little guy right here is pronounced H sub 0. H sub 0. The word sub is short for subscript. Right, these little numbers here are called subscripts. And I'm sure you've seen them in science class before. H2O. All right, so this is pronounced H sub 0. And it just means initial height or beginning height, starting height. But that's really the y-intercept. So this is actually the same thing as C. So H sub 0 and C are the exact same thing. So a question I usually get is, well, Mrs. Stoltz, why didn't they just write C in the formula? Why did they give us something else? Well, you have to understand is, like, at some point math and science overlap, right? So it's our job to make sure we're including science symbols and stuff. So science typically doesn't use C for starting amount, for y-intercept. They don't really call it a y-intercept in science. They call it an initial amount or initial height. So we want to make sure that you've seen the language that the science classes write in as well. So we just have to show you their notations as well, but these are the same thing. All right, and then the V stands for velocity and the 0 stands for initial. So we have initial velocity, and we would use plus if the object was thrown upwards, and we would use minus if it was thrown downwards. So if it's an upwards plus, downwards minus, but that's kind of common sense. All right. So I always pose this question to my students. I'm like, so why do you think we use 16t squared? Where does that come from? And the answer is it comes from physics. So a common physics formula is distance traveled equals 1/2 times the acceleration due to gravity times time squared. And you're not going to be quizzed on this. This is just kind of giving you a little background of where this comes from. All right. So gravity has a certain rate at which objects accelerate due to it. That's that force. All right. So that's what that stands for. The acceleration rate due to gravity is 32 feet per square second. Right. So that would go in for G. So if I put 32 in for G, well, half of 32 is 16. There's your 16t squared. Okay, so we use this because of gravity. So the negative 16t squared, you could be like, oh, that's representative of gravity pulling the object towards the Earth. All right. Now, you don't have to memorize these formulas. We give them to you, but you do have to memorize what these things stand for. Like, what does this H sub 0 stand for? What does V sub 0 stand for? Because you're going to need to know where to plug in your information. All right, so our first scenario is that we have a baseball player. He hits a foul ball straight up in the air from a height of 4 feet with an initial velocity of 85 feet per second. So if I was you, I would label my 4 feet H sub 0 because that's the starting height of the ball. Right, from the point at which he made contact, that's how high it was. So that's the beginning height. And then the initial velocity, you want to label as V sub 0. Now letter A says write a quadratic function that shows the height of the ball in terms of t seconds. And I do want to point out, it says the ball was hit up in the air, right? So my formula is such, it's h of t equals negative 16t squared. We're going to use the plus symbol for up. And then it's our velocity, initial velocity, t, plus h sub 0. So really all you're doing is you're plugging in your velocity and your starting height. That's it. You're just copying the formula and putting in those two. You're always going to have the 16 here because we're going to have gravity. All right, and that's it. A is done. Now letter B says, in how many seconds will the ball reach its max? So I see that word max. It's either H or K they want. Because they're asking for time, that's a when, that means H. So letter B wants H. So your job is to use your formula to get H. All right, so we have negative b over 2a. And I just realized I have a typo here. This should be 2 times negative 16. Got a little ahead of myself there. All right, so 2 times 16 is negative 32, not 64. All right, and that's when I would pull out my calculator. So we have to do 85 divided by 32, which is about 2.6. We'll round it to 2.7. 2.7 seconds. All right, and that's your answer. Now the last question says, what is the max height? So there's the word max, and because it's a what, they want K. All right, so I'm going to take my 2.7 and I'm going to plug it in for T. Now you don't want to copy this because I have the wrong H here. You want to use 2.7 for this. So we're going to change that real quick. All right. All right, we're going to type that in our calculator. Again, type it all in one shot. So much easier. 216 times 2.7 squared plus 85 times, 2.7 plus 4. And you're going to get, this guy doubled, 116.6. Sorry, 116.9. And that's my answer for K. All right, so you did your first velocity problem. We're going to keep these physics problems very basic. All right, we'll give you the information just so you can plug them in the formula. All right, so we'll do a couple more in our next video and just give you some practice with that. And we'll probably do a dropped object one as well.